Hello and welcome to this video. In this video, we will solve problem number 71 to 75 of arithmetic progression. It is kind of the place where we will sort of stop doing arithmetic progression problems. But this is not the end because we have not yet discussed arithmetic means problems. I will discuss arithmetic means, geometric means, and harmonic means at the same time once we have covered both geometric progression and harmonic progression. And later on, we will deal with some difficult problems of progressions and sequence and series. So it's not sort of the last video on arithmetic progression, but in terms of continuation, yes, it will take a break for now. So let's get started with our problem number 71. Problem number 71 says that if the sum of m terms of an AP is n and the sum of its n terms is m, show that the sum of m plus n terms is minus m plus n. So this is a pretty simple and straightforward problem. I mean, most problems are usually pretty simple. So as always, we let A to be the first term and D to be the common difference of the arithmetic progression. Now we are given that sum of m terms is n and sum of n terms is m. So we substitute in the formula for sum of m terms, which gives us m by 2 into 2a plus m minus 1 into d is equal to n. So we take 2 to the numerator of right hand side and m to the denominator of right hand side. We get the value 2a plus m minus 1 into d is equal to 2n by m. And from the other one, we get 2a plus n minus 1 into d is equal to 2m by n. So we subtract both of them to get d as minus 2 into m plus n by mn. Now we substitute with the value of this d in Sm, and we get the value of 2a as 2n square plus 2m square plus 2mn minus 2m minus 2n by mn. Now we substitute the value of 2a and d into the formula for sum of m plus n terms, and we arrive at the result kind of by solving this big one. But it is very simple actually. If you look carefully at all the terms, 2n square, 2m square get cancelled, 2mn gets cancelled to 1 2mn. There are three terms with 2mn. 2m gets cancelled with 2m, 2n gets cancelled with 2n. Finally, you are left with minus 2mn at the top. Mn will get cancelled with mn, and 2 will get cancelled with 2. Minus 1 will carry and get multiplied to m plus n, so that will give you minus m plus n. Now, problem number 72 says that if S be the sum of 2n plus 1 terms of an AP and S1 that of alternate terms beginning with the first, then show that S by S1 is equal to 2n plus 1 by n plus 1. Now, as always, A is the first term and D is the common difference. So we substitute the values for formula of n terms. So we get S is equal to 2n plus 1 by 2 into 2a plus 2nd because it will be actually 2n plus 1 minus 1d, which I have written as 2nd. And S1 will be n plus 1 by 2 because there will be n plus 1 terms since it begins with the first term but it alternates. So number of terms will be n plus 1, and then by dividing that you get the ratio as what is desired. Now, problem number 73 says that if A, B, C be the first, third, and nth term, respectively, of an AP, prove that the sum of n terms is C plus A by 2 plus C square minus A square by B minus A. So we have given as A, B is equal to A plus 2D because B is third term. If you have not looked carefully, then you should look carefully. B is actually third term, not second term. And C is equal to n plus n minus 1 into D. So from the formula of B, we find that B minus A is equal to 2D. So D is equal to B minus A by 2. From the formula for C, we find that D is equal to C minus A by n minus 1. And then we substitute for D, and we finally arrive at n is equal to 2 into c minus a by b minus a plus 1. We substitute these into Sn and we arrive at the desired formula. Now, problem number 73 says, hey, hang on. Oh, this should be problem number 74. There's a counting mistake. All right. So, problem number 74, that means others will also be wrong, right? Yeah. So, there are actually 6 problems in this. Okay. So, problem number 74 says that if the pth term of an AP is x and qth term is y, show that the sum of p plus q terms is p plus q by 2 multiplied with x plus y plus x minus y by p minus q. Now, like one of the previous problem, we have Tp is equal to x, Tq is equal to y. We subtract, and then we have d as x minus y by p minus 1. And hang on, it should be p minus q. X minus y by p minus q. It should not be p minus 1. And that's a typing mistake. Now we substitute this value of d into Tp, we get a is equal to x minus p minus 1 by x minus y by p minus q. And we substitute the value of this a and d into sp plus q. And we simplify to eventually arrive at the result. The result is not shown, but from what you can see at the visible last line, 2x minus x will become x, and then it will be x plus y plus x minus y by p minus q, which is what we need. Now, problem number 75 says that this is 75. All right, I have missed one. So the sum of n terms of two series is NAP are in ratio 3n plus 1 is to 8. 3n plus 8 is to 7n plus 15. Find the ratio of their 12 terms. So we let a1, a2 to be the first terms and d1, d2 be the common ratios. Common differences, not ratios. And then we substitute for the formula for sum of a series. Then we have 2a1 plus n minus 1 into d1 by 2a2 plus n minus 1 into d2 is equal to 3n plus 8 by 7n plus 15. And since we have to arrive at 11 for ratio of 12 terms, if we look carefully, we will need 22 for n minus 1. And then we have the same ratio, right? But if n minus 1 is 22, then n should be 23. So by doing sort of back calculation, we substitute n is equal to 23 in the equation, in the ratio for sum of series, and we arrive at the ratio of 12 terms as 7 is to 16. Now, problem number 76 says that if the ratio of the sum of m terms and n terms of an AP is m square is to n square, prove that the ratio of its mth and nth term will be 2m minus 1 is to 2n minus 1. Now, we substitute the values of a and d and m and n, all these things into the formula for sum of n terms of an AP, and we arrived at the value 2a plus m minus 1 into d by 2a plus n minus 1 into d is equal to m by n. Now, we substitute for the ratio of a plus m minus 1 into d, not substitute, we calculate actually. The ratio of mth and nth term as a plus m minus 1 into d by a plus n minus 1 into d. And then we multiply both numerator and denominator with 2a. So we will have 2a plus 2m minus 2 into d, 2a plus 2n minus 2 into d. We write 2m minus 2 and 2n minus 2 as 2m minus 1 into d and 2n minus 1 into d. So if you look carefully at the ratio of mth terms and nth term to the ratio of sum of series, then you will quickly realize that if we substitute m as 2m minus 1 and n as 2n minus 1 in the sum of series formula, then we will have our answer. So we substitute it there and we get the ratio of mth and nth terms as 2m minus 1 is to 2n minus 1. So this is where I'll conclude the video, and I hope that you have enjoyed the video. and maybe you should like actually because it motivates me, and it's not some entertainment video. Like, so I do get very few likes because very few people actually watch my videos. So if you watch the video and like it, then you should not forget to like the video. So we will start with geometric progression after this, and I'll see you in the next video. Thanks for watching.